Picture this. It's the 1980s and early 90s, and Japan is absolutely shocking the automotive world. We are talking about this explosive, lightning-in-a-bottle era where Japanese manufacturers had what felt like literally limitless R&D budgets. And the result? Machines that felt like they were pulled straight out of the future. Welcome to this explainer, where we're going to break down a heavyweight engineering battle between two absolute legends from this golden age. On one side, you have a giant-slaying motorcycle built to embarrass superbikes way above its weight class. On the other, a legendary sports compact car, powered by one of the absolute greatest naturally aspirated engines ever built. We're looking at two wildly different machines trying to solve the exact same problem: how to squeeze out maximum naturally aspirated power. All right, let's dive right into this. Here's our fight card for today. First, we'll look at Japan's golden age. Second, Yamaha's 5-valve revolution. Third, Toyota's high-revving 4AGE. Then, the engineering showdown. And finally, the legacy of these legends.
Section 1. Japan's Golden Age. So, to really grasp what makes these machines so special, we've got to look at the environment that birthed them. The 1980s saw this massive, unprecedented economic boom in Japan. And this wasn't just a period of, good sales numbers. It fueled an intense, high-stakes technology race across both the motorcycle industry and the sports compact car market. It was an all-out performance war. Right in the middle of this heated rivalry, Yamaha drops the FZ750 in 1986, completely changing the motorcycle landscape. A few years later, riding that exact same wave of relentless innovation, Toyota introduces the legendary AE92 and AE101 generations of the Corolla Levin in 1992. These machines aren't just vehicles, they're direct products of a very specific moment in history.
And that brings us to the foundational truth of this era. Unlimited budgets meant unlimited innovation. Seriously, without the usual financial constraints holding them back, these engineers weren't just answering to accountants anymore. They were given total free rein to experiment with some wild, revolutionary ideas just to crush the competition. This wasn't about cutting costs, no, it was about pushing the absolute boundaries of physics and engineering.
Moving on to Section 2, Yamaha's 5-valve revolution.
So Yamaha built the FZ750 with one clear goal: absolutely crush much larger superbikes from heavy hitters like Honda and Suzuki. But how do you beat a bigger engine? Well, you make yours breathe better. And that brings us to a staggering number: 20. Yep, 20. The FZ750 featured a 749cc inline-4 DOHC engine packing 20 valves. That is 5 valves per single cylinder. Think of valves kind of like the lungs of an engine. The more air you can pull in and push out, the more power you're going to make. By cramming 3 intake valves and 2 exhaust valves into this highly optimized combustion chamber, Yamaha basically allowed this engine to take massive, deep breaths at insanely high RPMs. And this brilliantly illustrates the shared genius behind Yamaha's famous Genesis engine technology. You see, they didn't just throw more valves at the problem, they fundamentally changed the geometry of the engine itself. They tilted the whole engine block forward, and doing that achieved two pretty incredible things. First, it created perfectly straight intake ports, meaning the air didn't have to bend to get into the cylinders, which drastically improved combustion efficiency and airflow. Second, it pushed the center of gravity downward and forward, a concept engineers call mass centralization. So not only is the engine breathing better, but the bike's handling and cornering were radically improved. Talk about a win-win. But hey, all that screaming top-end power is completely useless if you can't actually get it to the pavement, right? Yamaha used a highly efficient sequential gearbox to translate all that power to the rear wheel. When the rider shifts, the gear selector drum rotates, which moves the shift forks. Those forks then engage the constant mesh gears, instantly sending that visceral, raw power straight through the clutch and out to the chain drive. It's this beautifully violent, rapid-fire sequence that keeps the engine screaming right in its optimal power band, without losing an ounce of momentum. Which brings us to Section 3. Toyota's high-revving 4AGE. So what happens when you take that limitless Japanese R&D money and apply it to 4 wheels instead of 2? Well, Toyota's engineers faced a pretty unique challenge with the Corolla Levin. They wanted a lightweight sports compact car that had track-level power, sure, but it still had to be practical enough for daily driving and decent fuel economy. Their answer to this? Variable valve timing, or VVT. The crucial thing to understand here is that instead of having static valve timing, which basically forces you to compromise between low-end punch and high-end power, VVT dynamically alters exactly when the engine's 16 valves open and close. It effectively gives the engine 2 totally distinct personalities. Let's break down how this actually builds into an incredible driving experience. At lower speeds, the intake runners are optimized to prioritize low RPM torque, so the car feels really punchy and responsive around town. But when you mash the gas pedal and climb the rev range, VVT engages. Suddenly, the engine alters its valve timing, the airflow volume increases drastically, and the engine's high RPM breathing peaks. It is literally like a sprinter catching a sudden second wind right when they hit their top speed. It transforms what is essentially a humble 1.6-liter block into an absolute screaming performance machine.
All right, Section 4, the engineering showdown.
So here is the million-dollar question. We've seen Yamaha's brute force airflow approach and Toyota's dynamic shape-shifting VVT. Both of these manufacturers were trying to solve the exact same problem, getting the most power out of a naturally aspirated engine. So why did Yamaha insist on 5 valves, while Toyota stuck with 4?
Well, it all comes down to fundamentally different engineering strategies. Yamaha's 5-valve setup is all about maximizing pure top-end flow. By dedicating 3 of those valves entirely to intake, they achieved a much higher power per liter output, but it was deeply dependent on those straight intake ports from that tilted Genesis block. Toyota, on the other hand, took the 4-valve route, but paired it with VVT, and this allowed them to perfectly balance low-end torque with high RPM power. It gave them better fuel economy for a heavier passenger car, all while maintaining relative mechanical simplicity. I mean, compared to cramming 5 valves into a single cylinder, 4 starts to look pretty reasonable.
Now, what's really fascinating here is how these engine designs essentially dictate the entire personality of the vehicle. The Yamaha's 749cc 5-valve engine, paired with that rapid sequential gearbox, had a primary goal: track-level top speed and visceral razor-edge acceleration. It's aggressive. On the flip side, the Levin's 1.6-liter 4 AGE, paired with a manual gearbox and a limited slip differential, was designed for balance. Combined with its MechVerse strut suspension geometry, the Toyota was built for corner carving, managing weight transfer, and genuine everyday usability.
But if we're looking at pure, raw engineering efficiency, why does the motorcycle take the crown for horsepower per liter? It's simple physics, really. A motorcycle engine can rev much higher than a car engine. The internal components, the pistons, the connecting rods, the crankshaft, they are significantly smaller and lighter in the 749cc Yamaha than in the 1.6-liter Toyota. Less mass means less inertia, allowing the FZ750 to spin up to astonishing redlines with super aggressive combustion chamber angles. It extracts just an incredible amount of power per liter compared to literally any standard 80s vehicle, and it even edges out the highly tuned Levin.
And finally, Section 5, Legacy of the Legends.
Now, these machines are incredible pieces of history, but let's be real for a second. Reverence doesn't mean perfection. If you want to own one of these today, you got to face some objective mechanical realities. These are highly complex, high-revving machines that have, frankly, lived hard lives. On the Yamaha, just trying to keep 20-valve carburetors perfectly synced, that's enough to make a grown mechanic cry. On the Toyota side, that legendary 4AG is pretty famous for developing oil leaks over time. And of course, both of them suffer from aging cooling systems and the inevitable enemy of all 80s and 90s Japanese vehicles, chassis and body rust.
But despite all those headaches, their status as absolute classics is skyrocketing right now. But let this be a warning for sure. While the initial purchase price might actually seem kind of accessible, true restoration requires deep pockets. There is a real scarcity of original parts for the Yamaha, meaning a meticulous inspection before buying is absolutely mandatory. Actually though, it's worth contrasting that with the Toyota Levin. The Levin still benefits from massive aftermarket support today, largely thanks to its legendary motorsport success and a super active modification scene, which makes the car significantly easier to keep on the road. Which leaves us with this final thought. We've seen how the insane economic boom of the 80s and 90s gave engineers the absolute financial freedom to build wild things like the 20-valve Genesis engine and the dynamic VVT 4AG. They pushed the very limits of naturally aspirated performance, creating these analog masterpieces that literally paved the way for the modern performance tech we enjoy today. So I leave you with this. If limitless budgets and a sheer passion for pure performance created these mechanical legends over 30 years ago, what is stopping today's engineers from doing the exact same thing? Thank you so much for joining me on this explainer, and I hope this sparks your curiosity to keep digging into the fascinating history of automotive engineering.